In this lesson, I will talk about problem involving network. Have a look. Table below shows type of fruits flavor by some of the students. So you have type of fruits and the name of the students. Based on the table, draw a graph with multiple edges. To draw a graph, two main components, vertex, edges. However, we have a problem here. Which one should be your vertex and edges? Because it does not state food or students. Now the keyword here is to identify the pattern and you decide. Okay, what does it mean? I will get you through to understand what happens if we use student as vertex, what happens if we use food as vertex. So at the first, let's go with student as vertex. Okay, if you have a look on the graph over here, you realize that we go for student as vertex, and all the students here are Raj, Helen, Wong, Melvin, I. All these students are in the group of chicken rice. So chicken rice will be the vertex for, chicken rice will be the edges for the graph. The food as edges, student as vertex, and this is how you can relate 5 of them like chicken rice. Am I right? So if I do this for nasi lemak, the same kind of graph for nasi lemak, and I do the same kind of thing for 5 rice, and I do the same kind of thing for 5 noodles, still student as vertices, and then overall I will have something like this. Let's have a look on the criteria. It must be a graph with multiple edges. Can you actually call this as a graph? You have 4 little graph here, right? You have 4 little graph here. Can you actually call this a graph? The answer is yes. You can actually call this a graph. These 4 little graph, you put them together, you can actually regard this as a graph, no problem. Does it have multiple edges? Multiple edges meaning you have more than one edge connecting two vertices. In this case, you do not have any curved line, am I right? So it does not fulfill the case of multiple edges. So all the graph over here is incorrect. Okay, what if we still use student as vertices and see what else can we do? If we still use student as vertices and I want to have multiple edges, then depending on whether you can find the pattern or not. If you have a look on chicken rice and nasi lemak, you realize that Melvin and also I, both of them like chicken rice and nasi lemak. Now this is the case where you have the repeated one, meaning multiple edges. Repeated case, multiple edges. So you can draw Melvin and I, both of them like nasi lemak and chicken rice. Nasi lemak and chicken rice. This is where you have multiple edges. And then the rest, how about the rest? The rest is maybe I can put in chicken rice. The rest of the students, which is Raj, Wong, and Helen, they also like to eat chicken rice, but there's no multiple edges over there. So can I do something like this? Okay, we go on and see. If I do the same thing for still Melvin and I, but this time around still you have nasi lemak and chicken rice, multiple edges, but this time around I focus on nasi lemak, where I have Nulu, Atika, and Puspa. So still multiple edges. I do it this way. Can you imagine? Can you predict what is the next graph is going to look like? Eventually, you have something like this. Am I right? For 5 rice, but this time around, not Melvin and I, but Farouk and Julia. They like fried rice and 5 noodles. So you have multiple edges again, and then another pair where you have multiple edges and together with some of the simple graph. So in the end, you will have something like this. I've listed out 4 graphs over here, but that is not the complete graph, because if you look closely, this 4 little graph does not clearly represent all the relationship between food and students. No, this is incomplete. I'm just showing you 4. Okay, you need to draw more than that. So this is a graph, right? Okay, if I'm able to draw every single one, maybe 6 or 7 or 8, something like this, a graph something like this, then maybe I can complete it. If I'm able to complete this one, can you consider it as a graph? You have maybe 8 little graph and then you regard this as a graph. Yes, it's a graph. Does it have multiple edges? Yes. So technically, this can be accepted if I'm able to list out all the little graph for every single relationship. Okay, how many? I don't know. Okay, but even though this answer is acceptable, but is it the best answer that we can offer? Right. Okay, just now we go for students, sorry. Just now we go for student as the vertex. Have we ever tried whether we can use food as vertex? Okay, same thing. The keyword here is to identify the patterns. Chicken rice, chicken rice. Chicken rice, nasi lemak. Melvin, Melvin, I. So multiple edges, right? So this is not the only pair. Like I showed you just now. You can have a pair with Farouk and Julia, fried rice and fried noodle. You also have chicken rice and fried noodle, chicken rice and fried noodle between Raj Wong and also Raj Wong, another multiple edges, and another multiple edges, fried rice, nasi lemak, Nurul Puspa. So there are 4 pair of multiple edges, and you also have simple graph. For example, chicken rice, fried rice, Heron, no other people. Chicken rice, chicken rice, fried rice, only Helen's. And then same thing happened to Atika also, nasi lemak and fried noodle. And then you have 4 multiple edges, 4 pair of multiple edges and 2 simple graph. See how you can play around with them. Can you connect them? In the end, if you try, you have something like this. Okay, this is taking food as the vertices. So, is this acceptable? Draw a graph. Is it a graph? Yes. Does it have multiple edges? Yes, so it's a graph. Is it acceptable? Yes. Okay, so you have 2 acceptable answers. So this is where you take the fruits as vertices. This is where you take students as vertices. Am I right? The one on the right is not complete, okay? Because you need to draw more than 4 to clearly state the relationship. For example, let's say you take in Raj and Wong. Raj and Wong, both of them like chicken rice and fried noodles. But if you have a look in the 4 little graph here, it does not show. It does not show. You need to have drawn more to represent the relationship. So if you compare food as vertices and student as vertices, which give you a better answer? Which is a better answer? Now, the answer is foods. We should go for food as vertices because why? Because with 1 little graph, it clearly shows all the relationship between the food and the students. It's more suitable, it's more precise. I don't think I need to convince you. So if that's the case, we will go for this one as our final answer, a better ones, food as the vertices. And then we go on with the following question. Based on the type of food and the name of the student, which group you use to represent the vertices? I'll go for type of foods, as I mentioned, because it provides, produce a more suitable, which is appropriate, and precise graph, right? And then we go on with C. What is the relationship between the sum of degree of your graph and total number of food choices? Sum of degree, the formula, sum of degree 2 multiplied with number of edges, goods. When you have a look on the graph here, what is the number of edges here? You have 10. So you have 2 multiplied by 10 and you have 20. So sum of degree equals to 20. Okay, how about food choices? How many food choices do we have? You have chicken rice, nasi lemak, fried noodle and fried rice. So you have 4 food choices. The relationship between 20 and 4, because sum of degree is 20, food choices is 4. How can you relate to? Okay, when you think of sum of degree, if you have a look on the degree of chicken rice, the degree of vertex of chicken rice, how many edges connecting to it? You realize that it is 5, and then 5 for nasi lemak, 5 for fried noodle, 5 for fried rice. So you have 20, you have 4, you have 5. What can you relate? 5 multiplied by 4 equals to 20, right? So if you have 20 equals to 4 multiplied by 5, what are those? Okay, 20 is the sum of degree. 4 is the food choices. And 5 represent what? Degree of vertex for each one, each degree of vertex. What is it? Actually, that is the degree of vertex, actually is the name of the student in one group. If you look at the table, it's basically, this is the degree of vertices of chicken rice. So this is the number of students in a group. Number of students in a group. Okay, so this is a relationship. Sum of degree equals to food choices multiplies the number of students in a group. And then the last question, between the table form, which form is easier in showing the relationship between the food and the students? If you look at this one, at the first look, when you have a look on the table, chicken rice, you only can tell that these 5 students, they like chicken rice at the first look. But if you have the first look on the graph one, not only it tells you 5 students like chicken rice, it also tells you that Melvin and I, they like chicken rice, both of them. They also like nasi lemak. So it's very clear, it's very precise. So which one is better way of presenting graph form? Okay, and the next one, the following undirected graph shows 6 houses in village A. Salesperson need to visit all houses. So every vertices must be connected. All the vertices are connected. Start from A, N, F, F. So this is your starting point, this is your ending point. For this kind of problem, you just need to try. What is the shortest distance? Because you need to find the shortest distance. All the path taken once, meaning no, one way only. So no going back. But if you go for CE and EF, it's wrong. Why? Because this does not connect the vertex B. So no, that's not the case. Okay, so this should be the shortest distance. You draw it out and then you calculate it. It should be 3.05 km. Okay.